Okay, in the last video, we had this same graph here, and we found an equation for this graph as a sine function. This time, we're going to take the same graph, but we're going to find an equation of this same graph using a cosine function. Okay, and the reason that we can think of this as a cosine graph is because if we consider this the starting point and this the ending point for one period, for one cycle of the graph, then it looks like a cosine graph, right? A cosine function. So this is what we're going to use for the starting point and ending point in order to find an equation using a cosine function. So as a cosine curve, the starting point is here. Now, if this is pi halves, this will be pi fourths. Okay, if it goes out to 2 pi here, and this is pi, then this would be 3 pi halves. So each increment is pi fourths. So here this ending point will be at 5 pi fourths. This will be the ending point for one period of the graph. Okay. So our general form for this cosine curve is y equals k plus a cosine of bx plus c. That's a general form for any cosine curve. Okay, so step 2. Step 1 was to decide if we're graphing sine or cosine. In step 1, we decided we're graphing cosine. Step 2 is to determine the center line, or that is also called the midline. So one way to calculate that center line or midline is to take the maximum value and add the minimum value and then divide by 2. The max y value is 3. The minimum y value is at a -3. 3 plus -3 is 0. Divided by 2 is 0. That's one way to calculate it. Okay, so -3 plus 3 divided by 2. But it's also just vertically, if it's shifted, if the center of the graph is shifted up or down, then however far it's shifted up or down, that is your center line or your midline. Since this graph is centered about the x-axis, it is 0. So k is 0. That the center line is our k value. Step 3 is finding the amplitude. The amplitude is the distance from the center line to the top of the graph. For this graph, the distance from the center line to the top is 3. So our amplitude is 3, and our amplitude is a. So a is equal to 3. For step 4, step 4 is calculating the period, looking at the graph of finding the period, and then using the formula for the period. Okay, so for this graph, the period, well, for any graph, the period is the ending point minus the starting point. For this graph, if we're thinking of it as a cosine curve, the ending point is at 5 pi fourths for one period. The starting point for that period is pi fourths. Right? Starting point is pi fourths. The ending point is 5 pi fourths. And so make sure I'm showing the right part of the graph here. So the period is the ending point minus the starting point. 5 pi fourths minus pi fourths, which equals pi. Okay, so the period is equal to pi. Now, the formula for the period is 2 pi over b. So since the formula for the period is 2 pi over b, and this period is equal to pi, then 2 pi over b equals pi. If you cross multiply, then b times pi equals 2 pi. Divide both sides by pi, and then we get b equals 2. So now we've got b. So we have k, a, and b. Now we need c. We get c by finding the phase shift. Okay, the phase shift is equal to the starting point, and we've already looked at the graph and said the starting point is at pi-fourths for this cosine graph. Now the starting point is equal to pi-fourths, that's the phase shift. And the phase shift, the formula for phase shift is negative c over b. So negative c over b is equal to that phase shift, which is the starting point. So negative c over b equals pi over 4. Then we cross multiply. Oh, first, sorry. We have negative c over b is equal to pi-fourths. Since negative c over b is a formula for the phase shift, and pi-fourths is our starting point for this graph, which is the phase shift also. So we replace b with 2 because we found that in the previous step. So negative c over b becomes negative c over 2, which is equal to pi-fourths. Now we cross multiply. So we have negative c times 4 equals 2 pi, and then divide both sides by negative 4, so we get c equals negative pi halves. Now that we have k, a, b, and c, we plug all of them into the general equation for cosine. The general equation was up here, y equals k plus a cosine of bx plus c. So we plug those in, we end up with y equals 0 plus 3 cosine of 2x minus pi halves. And then getting rid of the zeros, then we have these 0. We have y equals 3 cosine of 2x minus pi halves.